Hi y'all, this is Rational Exponents Notes 59. So today we're going to be talking about what happens when you have something to the power of something like 1/2, or like 27 to the power of 2/3, something like that. So as you saw on your calculator, like we saw something a little bit like this, and we saw that the denominator moves out in front of and becomes the index. So what that means is if we have something like x to the power of a over b, that the b is going to come out in front and becomes the index, right? And then the a is going to stay here and stay as the exponent. So if I'm thinking about this in like a super mathematical way, what that means is that this n is coming out in front. So for all real numbers b and any positive integer n, the n becomes the index. The denominator becomes the index. So I'm going to go ahead and write denominator equals index. The base is going to stay exactly the same, so I'll just use black. The base is still there. And then that 1, or the numerator, is going to stay as the exponent. So the numerator equals the exponent. All right, so it's just a real quick switcheroo. So, for example, if we see this 27, so here we have 27 and we have to the power of 2/3, right? So what happens is the 3 swings out in front and becomes the index, as we see here, and the 2 stays as the exponent. So we can write it in two separate ways here. We can write it as where we do the cube root first, and then we get 2, or take it to the power of 2, or we can do the square first, and then we can do the cube root. So it's really up to you and what seems easiest to you. So in this case, we would do the cube root of 27, which is 3, and then we put the square on, and 3 squared is 9. In this case, we would have 27 squared, which would be 729, and we take the cube root of that. The cube root of that is 9. So either way, we're getting our eventual answer of 9. It's just whichever one you want to do first. So the directions here are, if it's in exponential form, you're going to write it with a radical in radical form. If it's in radical form, you'll write it in exponential form. So here, I would take my denominator, move it out in front, and I get 6. And then I have my x stays in the same place, and then I have a 1 there. I don't have to write it. I can if I want. So that would be my answer for that one. It was in exponential form with an exponent, and now it's in radical form with a radical. All right, number 2. Number 2 is in radical form already. So I know that this has an exponent of 1, right? So I have z to the 1, and it's the 4th root of that. So I take my 4, it goes to the bottom because it's a denominator, and it goes z to the power of 1 over 4. This was in radical version, and I put it into exponential version. Go ahead and do that for number 3 and 4 now. So you're doing number 3 and number 4. You can pause your video if you want. You obviously don't have to write the word pause there. Just for people who aren't listening. All right, so for this one, these ones we have numbers here. So we can say, okay, I'm going to take this 3. I'm going to push it out in front. So I get 3, and I get 343, and then I still have my square there. You could square it, but that's going to give you a huge number. So what I'm going to do first is the cube root. The cube root of 343 is 7, and I still have my square from before. This square still comes right here, and 7 squared is 49. So we'd say this answer is 49. Go ahead and try number 6. Number 7, and then try number 8. Go ahead and pause your video, and go ahead. Okay, hopefully you're back. And we're going to simplify expressions. So essentially what we're saying is that the rules are the same. So if we have something like a to the 3rd times a to the 10th, we would have a to the 13th because we add our exponents there. If we had something like a to the 3rd to the 10th, something like that, we would have a to the 30. So I see parentheses, so I know that that means multiply. Another one we might see is a to the 10th over a to the 3rd. That would be the same as a to the 10 minus 3, which is a to the 7th. The 7s are left, or a to the 7th is left on the top, the numerator, because the 10 is bigger than the 3. And then the last one that you may or may not remember is a to the negative 10 is actually the same as saying 1 over a to the positive 10. So if I see a negative exponent, I'm going to move it down here. That one's really important and one that we forget, so I'm going to go ahead and write it. Negative exponents. Move the term to the bottom. Or the top if it's on the bottom already. So move it to the bottom. Sweet. So in number 1, I see something that looks very similar to this one here. It has 2 A's, and so we know our answer is going to be A. And then we know that when we are multiplying, we're adding our exponents. So I have 2 sevenths plus 4 sevenths. That's going to give me a to the 6th sevenths. That's it, just like that. So we add our exponents. Fairly simple. Number 2, we see a negative exponent. So I'm going to use this rule here. Whenever I see a negative exponent, it's going to go to the bottom. So I'm going to have b to the 5/6. Right, so goes to the bottom. There's nothing on top, so we put a 1 there, and that would be our answer there. All right. Fairly simple. For number 3, I see things that are all being multiplied together. So I can see that this whole thing is like this version right there, and it combines with my negative exponent rules. So I'm going to go ahead and combine them together. This is like z to the negative 3/4 plus negative 1/4 plus negative 7/4. They all have fourths on the bottom, so negative 3 plus 1 is negative 4, plus 7 is negative 11. So I have z to the negative 11/4. And then I remember that negative exponents move the term to the bottom. So I know that this turns to z to the 11/4 on bottom. Nothing left on top, so I'm going to put a 1 up there. All right. For number 4, on this one, I see that I have z to the 5/3. I know that I combine these by adding, so I would have z to the 6/3, because 2 plus 4 is 6/3. And then I see that there are 6/3 is bigger than 5/3, and so I know that the z's are gonna be left on the bottom, and I can do 6/3 minus 5/3 would be 1/3 left on the bottom because there are more of them down here, and there's nothing left on top, so I put a 1. That would be my answer for number 4. Okay. See number 7 here. Not sure why it's number 7, but I'm going to think about it. It says, explain why the expression, this thing, is not a real number. So I'm looking for a number. If I do this part first, I'm looking for 4 of them that would multiply to get negative 16. So number times a number times times a number times a number should give me negative 16. So you might think, well, what about 2? So 2 times 2 times 2 times 2 gives you positive 16. So that's not going to work. So then you're like, oh, I'm on the right track, though. I'll do negative 2, negative 2, negative 2, negative 2. But when I multiply these together, I get 4, and these get 4. And that's, again, positive 16. So that doesn't work. Let's back up. I could try a fraction. Not going to work. Nothing works. And so that's why it's not a real number. Nothing can be multiplied times itself 4 times. My desk is right. Multiplied times itself 4 times. Whoa. To get negative 16. All right, so that's why you can't get negative 16. You could use an imaginary number. An imaginary 2i would work, but not for now. So, all right. We don't have to think about that. Okay, so you're going to take a look at assignment 59. You're doing all the problems. The answers will be on the bottom of yours in a table, and they should all be used, so you can go ahead and find them. Same is true for page 5. Your homework is pages 4 and 5. If you are feeling good and you want to do some extra credit, level M, M-5, or M.6, those will be your extra credit. All right, y'all. Enjoy.